Okay, in this video we will be continuing our lesson on the subchapter 10.5, comparing to proportions. So the previous one was 1 hour long. It included 10 pages worth of review. So we'll be answering the 4 questions that I promised. So let's proceed. Again, for statistic for the equality of proportion, two proportions. We have x1, n1, an x2, an n2, and identify this is a two-tailed test. A is 0.05, survey of 100 show that 65 were loyal to one brand. Comparing the proportion of brand loyal customers is 0.05. So this is the success. This is the 100 is the sample size, and another 100 samples, and 53 were loyal to one brand. And that's for x2. So let's proceed. Let's solve for P1 and P2. For P1, we have 65 over 100. That's x1 over n1, which is basically 0.65. And then for P2, we have 53 over 100. That is 0.53. And then we have PC. PC is equal to x1 plus x2 over n1 plus n2. That is 0.59. Okay, for 0.59, we found the 3 values we need for the formula. Let's start with the step 1 first, the hypothesis testing. The enumeration of the hypothesis. So for HO, we have pi 1 minus pi 2, also for alternative pi 1 minus pi 2. And then because this is a two-tailed test, we have an equal sign and a not equal to sign. And then after that, we have we just write 0 there, and then critical. This is about proportion, test statistic for equality of proportions. So this is a z value. We use a z table, not the t table. So apply normal distribution process, 0.05. Because this is a two-tailed, 0.05 becomes a over 2. That means it's 0.025. And according to the sheet that I provided before, let's check it again. 0.025. Originally A is 0.05 and it's a two-tailed test, so it's this one, plus minus 1.960. You can see that 0.025 is over here. Okay. Now for step 2, reject HO if z-calc is less than negative 1.960 or z-calc is greater than positive 1.960. And then formula, z-calc is equal to P1 minus P2 over PC times the quantity 1 minus PC times the quantity 1 over n, 1 plus 1 over n2. So P1 minus P2, 0.65 minus 0.53 over PC, which is 0.59, times the quantity 1 minus PC again, so 1 minus 0.59, times the quantity 1 over n1, n1 is 100, plus 1 over n2, 1 over n2 is 1 over 100, and then scientific calculator, what does it say? So zcalc is equal to 1.725. Let's go to step 4. In order to be sure of step 4, let's draw this one. This is a two-tailed test, and the critical z value is 1.960. So this is 1.960. This one is negative 1.960. And then 1.725 is somewhere here. In this region, in a two-tailed test, generally speaking, this is the region of do not reject. Therefore, we fail to reject HO. That is our ruling for step 4. Is this a odd number exercise? Nope. So I can't assure you that this is correct, but yeah, it's yours to identify where I might be wrong. So 10.27, there's an answer key for that. So we'll be sure about the answer for this, most likely. So again, a x1 and 1 x2 and 2. What tailed test is this? It says perform a two-tailed test, so this is two-tailed. And then 20-minute consumer survey mailed 500 adults, that is the sample size, age 25 to 34, with a cyber certificate. 65 responses from the first group, 45 from the second group. Still 500 adults for each sample. The ones that were given a gift certificate, and those without a gift certificate. So it just shows here how incentives work. If there's an incentive, more people will participate in that survey. But if there's none, less people will be interested. So yeah, because this is a two-tailed test, we're trying to ask if there's any significant difference in if you provided an incentive or if you did not. So let's calculate for P1 and P2. So 65 over 500 is 0.13, and then 45 over 500 is 0.09. For PC, we have 65 plus 45 divided by 500 plus 500. So PC is 0.11. Now, for step 1, hypothesis, so HO and H1, pi 1 minus pi 2. This is a two-tailed, so it's an equal sign. For alternative hypothesis, pi 1 minus pi 2 is not equal to 0. Critical Z value is what? We have 0.05, and it's a two-tailed, so a over 2 is 0.025. I think we have the same thing. Yeah, it's the same as 10.26. We have plus minus 1.960. Okay, for step 2, we have reject HO if Z calc is less than negative 1.960 or Z calc is greater than positive 1.960. And for step 3, just copy paste the formula. Z calc is P1 minus P2. P1 minus P2 is 0.13 minus 0.09 over the square root of what's PC? PC is 0.11 times the quantity 1 minus 0.11 times the quantity 1 over n. N1 is 500, and then plus 1 over n2. Still the same, 1 over 500. And then, okay, 0.13, 0.09, 0.11 times the quantity 1 minus 0.11 times upon 1 over 500 plus 1 over 500. That is 2.021. Okay, step 4. Before that, let's check here. Plus minus 1.960. And then this region is 2.021. This region is reject. So reject HO. Let's see if my answer is the same as the book. So 10.27 reject at 0.05 equal to A. This is correct, this is correct, this is correct. Okay, good. 10.28, let's move on to 10.28. Again, let's rewrite the given that we'll be expecting. Okay. A is 0.05. What tail test is this? Use a left tail test. And then the Environmental Protection Agency found bacterial contamination in water. 20 out of 158. And then based on research improvements, 29 of 169. Randomly sampled flights. Okay, so that's everything for the given. Let's start with step 1. Wait, before we start with step 1, again, let's identify the P1 and P2 variables, and then later on the PC variable. So for P1 variable, it's x1 over n1, 20 over 158. In other words, that is 10 over 79. And then P2 is x2 over n2, that is 29 over 169. That is still the same, 29 over 169. I'm not writing the decimal because it's harder to write the decimal. It's way longer. So for PC, 20 plus 29 over 158 plus 169. This is 49 over 327. So step 1, HO and H1. I keep writing pi O. Pi O is associated with test statistic for proportion in a one sample. But this one is two samples, testing for the equality of two proportions. So yeah, this time we involve pi 1 and pi 2. This is a left tail test, so the inequality signs will be like this. Critical Z value. This is negative what? Because it's left tail, we know it's negative. But we haven't found the number yet, so let's use the table a while ago. So what does it say here? 0.05 and it's left tailed, so it goes here. It's negative 1.645. So let's go with step 2. Reject HO if Z calc is less than negative 1.645. Now let's go with step 3. Let's just copy paste the formula. Copy paste. P1 minus P2, that is 10 over 79 minus 29 over 169. And then over the square root, over the radical sign. Shucks, I forgot how to say this correctly. Sorry about that. Anyways, 49 over 327 times the quantity 1 minus 49 over 327. Yeah, it is a square root. Yeah, it's square root. 1 over n1, or 1 over 158, plus 1 over n2, 1 over 169. So, 10 over 79 minus 29 over 169 divided by, shucks, this is so much. 49 over 327 times quantity 1 minus 49 over 327 times the quantity 1 over 158 plus 1 over 169. This is negative 1.139, or negative 1.140. Okay, what is our ruling? This is a left tail test, so I think it's over here, the negative 1.645, the critical z value, and the critical, or the z calc is somewhere here, negative 1.140. In a left tail test, this is reject, this region is do not. So since negative 1.140, or our z calc, is located at the do not reject region, we do not reject, or we fail to reject, HO. I can't guarantee the right answer for 10.28, but it's quite the effort. Let's go to 10.29, the last question, and we're done with this video, finally. Okay, A is equal to 0.05. Is this a statistically significant difference? So this is ultimately a keyword for two-tailed test. K-normality, not sure, I can't answer this part yet. But for the test statistic, that's what I'm after. As well as the four hypotheses, the 4 steps that we do in hypothesis testing. Anyways, 14 of 180 failed. Sorry, 14 of 180. And compared to 7 of 67. I wonder if failure is the success or the X value, because it says 14 failed out of 180, but then X says it's the number of successes. Should it be 180 minus 14 to get X1, or is X1 already 14? Which do you think is better? Let's try. I'm not exactly sure, but we'll give it a try. Let's try to solve it the traditional way. Let's say 14 is a failure, which is a success in X1, and then total sample is 180. Total sample in N2 is 67, and the failure or the success in general is X2. I know what I'm saying is kind of contradictory to each other. It's kind of like an oxymoron, but then I don't know. Let's find out, because I'm not really sure as well. So P1, P2, and then PC. P1 is X1 over N1. That is 14 over 180. In other words, 7 over 90. For P2, it's 7 over 67. For PC, that is 14 plus 7 over 180 plus 67. So that's going to be 21 over 247. So let's start with step 1. HO H1. This is a two-tailed test, so equal and not equal sign. And 0, 0. Critical z value. What is it? This is a is equal to 0.05. So say a over 2 is 0.025. Why did we do this? Because it's a two-tailed test. So let's pull out our paper again. Two-tailed test 0.05. This is plus minus 1.960. Let's move to step 2. In step 2, reject HO if Z-calc is less than negative 1.960 or Z-calc is greater than positive 1.960. Step 3, Z-calc is equal to P1 minus P2 over square root of PC times the quantity 1 minus PC times the quantity 1 over N1 plus 1 over N2. P1 minus P2, this is 7 over 90 minus 7 over 67. PC is 21 over 247. Okay. We have 4.566. Plus minus 1.960, so 1 over there. And then 4.566 is somewhere here. This region is reject in the two-tailed test, so reject HO. Oops. Let's see if I have the same answer with the answer. So 10.29. Ha. Ha ha ha. What the heck? It says cannot reject. The question is why. Z-calc according to the ebook is equal to negative 0.669. Apparently this is correct. I think the ebook, the answer key says that we have to use a right tilt test for some reason, because the critical z value should be positive 1.960. I'm not sure though. It says here statistically significant difference. It didn't say if it increased or not, right? And yeah. Okay, let's try a right tilt test this time. We'll repeat the entire damn process. Yeah. Can't really blame myself. Teacher didn't really teach this part. And it's not exactly her fault, because we only have a few weeks to finish the last quarter of our grade 11. And here I am making mistakes. And the world will see them. Anyways, okay, let's make this right tilt test, for the hopes that things might change. You don't have to change anything in the P1, P2, and PC values. I started the hypothesis HO and H1 because this is a right tilt test. You have something like this and like that. For the critical Z value, we have positive 0.05, and it's a right tilt test, so .05 right tilt test goes here. It's positive 1.645, I think. Wait, no. What the heck? Ain't no way. The critical Z value is positive 1.960. I give up. It's actually two-tailed. But for some reason, the computation is like this. Screw it. I give up with 10.29. I'm sending this to my teacher. And yeah, I think we're done. Next video will be about 12.1, but I noticed that I failed to record a walkthrough for 10.4 comparing two means per sample. So this will be the next video. Kinda expect it. And yeah, I'll see you. Thank you for watching.